keep the time. I'm here together with Jan de Burlitz of Wageningen University, and he will start the session. How to assess the European environmental information systems. And then we'll have some, I hope we have an interesting session, some useful conversation on the chat, or if we have some time, also in the wider. So let me get the slides of Jan Dirk. Karen, I guess the video is now running, or are you starting that?
Okay. So also welcome from my side. My name is Jan de Burlitz. I'm working in Wageningen University and Research. And I have a short presentation to start off with, which is called How to Assess the Environmental Information Systems. It's what I present as part of the project we carried out past years for DG Environment. And the part I take out is about environmental information systems. And I will take you through that in a short while. So on the next slide, so probably you will wonder what the environmental information system will be. So happily there is a definition in GeoNetwork, which is not too short, by the way, but it is defined as a coordinated assemblage of people, devices, or other resources designed to exchange data or knowledge concerning any aspect of the ecosystem, the natural resources within, or more generally, the external factors surrounding and affecting human life. It's a mouthful. The project we carried out at DG Environment was about what is available in the European Union when it comes to information systems about the environment. This is going beyond what is only the data, so it's also the information. So if we go to the next slide, it will be telling you something about the basic principles. And probably everyone knows the knowledge pyramid, which is on the upper left side, which starts with data. Inspire is all about data, but data is basically depending on what data you have, without information. So you have to collect information or to create information based on data sources, probably more, especially in the environmental domain, especially more than one data set only. So then it comes to information that will have meaning, which will tell you more about what you are interested in, basically. And it goes further on, but I think we will skip the other two layers. At the lower right side, we see the MDIR schema, the framework which is used with the EA, where we also can see the information and data layer inside. If you click next, then you see that those are the things which. Okay, go back once. I still have to explain something about the other figure which you have on the lower left side, which means that there is a very concise schema, which on the left side you see the information systems, where you can look and search and try to discover. Discovery is one of the main items of this session. So you want to discover data and information on it. And the other two sides is one depicts more or less the information systems, which are basically websites of the different countries, member states, or different organizations within the member states, which tells you information. That information is basically also in text or documents or data. That can be everything. But the data, which is on the most right side of it, it is specifically stored in repositories. And the change between those are important because they indicate that it is linked together. So what we stated within this study we carried out is that if you have information without any data connected, then it will be useless. But the other side around is if you have data which has too little meaning, it's also worthless. So you have to be sure that you connect it. Discovering data, you have the documents or the graphs or the figures or whatever, but you have also to need the information underlying that to have a transparent idea about what that information means and how you can use it in the end. So this is a crucial notion which you have to have in mind. It's not only data, it's also the information, but the linkages is very important. So on the next slide, what we did in this project is that we carried out an inventory of what is around in the different member states, which delivered a number of lists. And of that list, we had for the 6 main environmental domains inventored what is the information which is inside. And the next slide will show you that the step we did afterwards is that we want to assess those systems. By the way, do they have enough information which makes it usable for the end user in the end? And we did that by defining criteria, 68 in total, and we clustered it in 4 different categories to make it more easy to understand how good practice would be done and what is the state of the different information systems in the countries. Those 4 categories, they have the governance, so how is the maintenance and providing and the search organized in a way. The content, which is basically the most important, of course, but also sharing. If you cannot share it, then it will be useless to have that information because you cannot use it in your own environment. And usability is something which makes it easy for the user, for the different target groups to use the information you want to know. So those criteria, we didn't invent it ourselves. So what we did is we selected it based on previous studies and reports like the fitness checks, like the Science Codebook and others as well. In the next slide, you can see that we did that on those, basically those criteria. So how is the, when it comes to governance, how is the national setup and how is it linked to Inspire? When it comes to content, does it contain the state of the environment reports and what about permits and licenses? And that for each domain, which is the subject of the specific systems we assessed. For usabilities, we had are the proper indicators provided, so you can make use of that, support offered. What is the overall experience to use the system and what is the appearance? How does it look like? Is it complex and is it complete? And about sharing, that's mostly the part we also discussed a lot within the Inspire community. So what kind of formats do you use? Is the content given to have some additional information if you want to? What are the conditions based on the licenses which are there? Is it open access and is it free of charge? So those are grouped together and that we assessed for basically all the member states. And in the next slide, you can see that we have clustered it also in the 4 categories as an overall in Europe, which is now, let's say this of a couple of years ago. And with only 1 criteria, 1 category, so to say, which scored well, which is sharing, and scores well means above 50%. The other ones are differently distributed. So usually for governance and content, 1/3 is okay, and 1/3 is not okay, and 1/3 is moderate, so to say. We also made a distinction in what that means for the different countries. And it gives you this overview. It is a very temporary kind of overview, but it gives an idea about what the status is. Overall, if you see this, it is not too bad in the end. So there are countries which perform better than other ones, but it is improving, I think, since that period of time. And also things like interoperability, which is only needed for Inspire this year to be fulfilled for most of the year of the teams within Inspire. It means that I think it will be changing rapidly. So this is an old image as well. Okay. To end up this short presentation, to have some reflection. So how can performance in the area be assessed? I think what we did, the method is very from a bird's eye view at one hand, but since we used a lot of criteria which were very essential, I think it's good. You can show relatively well the transparency which you have to be assessed. So that are the benefits if you do such an assessment. But this is only one side of the study we did. To finish that off is also that we try to, can we make a demonstrator in which we access or make it possible to access all these information systems we did inventory, and can you solve a certain question which you have. And so that demonstrator we created, and while doing that, there seemed to be a lot of problems to find data and to connect data and to link the data and the information. And basically, it's not that you cannot, it's not there because that we assessed already, but the issue is that it's not machine to machine readable in an easy way. So to connect it in that such a way, I think there still has to be done a lot of work in that area. Nevertheless, I think that it is promising, but we are not there yet. So if you want to have really automatic discovery of data for specific user questions from either the policy domain or from the citizens up to the citizens too, then still there has to be work to be done. Okay, I think I will leave it with this. Questions, if you have questions, we have questions at the end of the session. So keep them available and make them available in the chat if you like. And I think it's best to go straight away to have save times to the next presentation, which is carried out by Clara Boyd. And it's called the Evaluation Journey and Recommendations for Search Engine Optimizations in the UK. Are you ready, Clara?
Yes, thank you very much.
Okay.
Clara, thank you for joining us. I'm really excited to hear. You saw a presentation from your colleague Marion Pope last year at the JRC search engine workshop, and I was really enthusiastic about that. But then, so I wanted her on this show, but then she changed jobs, and happily with you standing up, I'll do that.
Yes, I have to say a massive thank you to Marianne because she has done some amazing work. So I feel very privileged to be able to present what she's been doing before she unfortunately left the Ordnance Survey. Can I share?
Should I? Do you share yourself, or should I put up slides?
I can share, that's fine. I think I've deleted a slide since I sent it to you already, Paul. So.
Okay, good. So let's share.
Is that available to be seen?
Yes.
Perfect. Thank you very much, everyone. My name is Clara Boyd, and I am a data standards manager working at the Ordnance Survey. So just as a bit of an introduction, I'm going to be presenting on a project that I was part of, which was commissioned by the Geospatial Commission. For those of you that don't know, the Geospatial Commission is a relatively new government entity in the UK, and we have 6 organisations that fall under the Geospatial Commission strategy. That is the Coal Authority, HM Land Registry, Valuation Office Agency, the UK Hydrographic Office, British Geological Survey and the Ordnance Survey. And we have been named the Geo6 in the UK. We have been completing a series of projects, and the one I'll be presenting on today is called Data Discoverability 2. Specifically looking at recommendations for SEO. So what did we find? Well, actually, there was a relatively incomplete picture of geospatial data in the UK, and for us that has led to quite a few inefficiencies and missed opportunities around discoverability, around usability in private and the public sector. So the Geospatial Commission decided to put a project together in collaboration with the Geo6 called Data Discoverability Part 1. We looked at various things such as how we publish and produce metadata. We looked at what websites we used, how we shared our metadata, and found that most of our organizations actually did it quite differently. So some would produce their metadata in an automated way, some would create it manually. Some of us had our websites hosted on gov.uk, where some of us had dedicated websites. But essentially, all of us posted and shared our metadata on data.gov.uk. So one of the findings from data discoverability part 1 was we did some user research, and we found that the majority of users actually don't go directly to portals. Most users use search engines, primarily Google. I will talk about Google quite a lot as it is the world leader, and use these to find data or to access portals if they don't know the portals they should be looking on. So lots of recommendations came out of DD1, as we call it, and we created a data discoverability 2 project. Again, the Geo6 collaborated on this project with the Geospatial Commission, and it was quite a large project compared to DD1. So it's split into 7 work streams, looking at a variety of different things around data discoverability, such as data sharing. We looked at glossaries of terms, and search engine optimization was one of those 7 work streams, and that's what I'll be focusing on for this presentation. So search engine optimization, what did we do? Well, we split our SEO review into 3 separate tasks to make sure that we had a good overview of different aspects of SEO, especially in the UK, and focusing on data publishing and geospatial data. So for the first one, we did a review of existing research that was already out there, already published, for data publishers or even by data publishers. Then we looked at website behavior for the Geo6 websites, and actually for data.gov.uk as well. We were very lucky to be able to use some of their data. And then finally, we asked some SEO specialists to have a look at the metadata we'd already produced and published on the web on data.gov.uk to see where we could improve or optimize what we are doing. For the review of existing research, we looked at literature and research from academic sources. We also looked at advice from search engine providers, and also Marianne attended the Inspired Discoverability workshop, which Paul mentioned earlier, last summer, which was looking at data discoverability for mainstream search engines. So what did we find from that research? Well, like DD1, we found that using search engines is the primary tool for finding data. We can't get away from the fact that Google is a world leader, and this was also found throughout other work streams of DD2. We also found that the more data there is on the web, the more difficult it is to find for users to find what they're looking for. And as portals get bigger and have more data available and metadata available on them, the importance of search engines increases dramatically. They become so important in being able to find what you need. We also found that when you have specialist portals, it can actually harm awareness of where to find data, and it can make it more difficult if you are a non-specialist. So if I'm a non-geospatial user and I want to find geospatial data, I might not know about those dedicated portals. So again, our ability to use search engines becomes dramatically important again. We also found that using structured data, quality metadata is one of the biggest impacts on whether your data is discoverable. Search engines look at the metadata as they're not often able to search the data itself, and any improvements you can make to metadata will actually have a big impact on how search engines such as Google are able to find and assess your website for where it will appear in their rankings. Also, another big topic, which I know came up quite a lot in the Inspired Discoverability workshop last year, was the use of structured data to ensure that websites are crawled. So using things like schema.org in your HTML is really common now to enable search engines to crawl and index the contents of that page to enable you to come up in search results. And the more we do this, the more our data becomes more discoverable. And finally, the importance of using sitemaps when it comes to metadata. So metadata is often what they call an orphaned page on a website. So it means that it's not necessarily linked or has a link from anywhere else in the website. This means using a sitemap and submitting that sitemap to Google means that they can find that orphan page, they can crawl them and index them in the same way as the rest of the website, which is really important to make sure that all the metadata is discoverable. So that was a really interesting piece of work, and it led to some more reviews on our web user behavior. So we were able to collect our website data. So this was Google Analytics, Google Search Console, and we were able to collect a variety of data from each Geo6 member, as well as data.gov.uk, who did participate in this project. We made sure all the data covered the same period of time to make sure that it was as valid as possible. And I would say the main finding from this, again, was the importance of Google. 4 out of 6 of the organizations, Google was their main traffic. And if you look at, for example, the British Geological Survey, it was over 70% of their traffic came from Google. You had data.gov.uk and UK Hydrographic Office, where although Google was a big influence, it wasn't their primary one, but you can see also how close they were. So what about the SEO review? Well, that came up with a lot of interesting things. So we asked an SEO expert to
Ja,
review 30 Geo6 metadata records that
wat zeg je?
the Geo6
Wat zeg
had.
je? Ik had oordopjes in hoor. Ik ga niet heel lang wachten. Totdat je verder gaat praten.
Is someone not on mute? Sorry. I'll carry on. So we asked an SEO review expert to review 30 Geo6 metadata records that had been published previously on data.gov.uk. And we found a variety of things that were actually really useful and things that you probably wouldn't necessarily think about. So often we had titles that were too long. This actually meant that in Google search results, the titles were truncated, and then it might mean that important parts of those titles weren't visible in Google. The experts have suggested that you should keep your titles of metadata to maybe 50 to 60 characters to avoid that truncation. It's actually based on the amount of pixels, so that's why it's 50 to 60, and sometimes it's a bit of trial to see how it comes up. The second thing is looking at the summaries, that they're not always optimal. Sometimes they aren't necessarily coherent, sometimes there is no summary at all. But to bear in mind that it's the summary that often appears in the Google preview in the search results. And it's normally roughly the first 120 characters. So optimizing this to attract people to click on your website page is really essential to making sure your data is discoverable. A really important thing to remember when using a portal as well is that Google doesn't see individual publishers. They see a portal. They see one website and one domain. So if you have a variety of publishers that are able to put their metadata and their data on that portal, you have to bear in mind the effects that publishers have on each other. So for example, if one publisher produces a really comprehensive optimal metadata record, it will bring up the appearance of the whole website to Google. Where if one publisher decides to not fill in their metadata correctly, or it has missing fields that Google wants to see, it will actually push you down and it will devalue you to Google. So I've got a couple of things that are more portal specific. So special characters, this is something that we use quite often in Ordnance Survey. And what we found is some portals don't recognize special characters, and then they become unreadable strings that Google essentially doesn't like. It sees them as something that doesn't make sense, and it will mark it down in its rankings. It also looks at the length of the URL. So as you can see here, you might have your subdomain, your domain, you might have variety of identifiers, or you might have the page title in your URL. But experts such as Neil Patel recommend that you should keep your URL to about 50 to 60 characters again, because there's actually a correlation between Google position and how many characters are in your URL. And you can see from the graph on the left that actually the more characters you've got, the lower you tend to be in the rankings. So a short, concise URL is actually very helpful, but appreciate that sometimes it's out of our control. So for data.gov.uk, we don't have control of what the URL that is produced looks like. So all of this work has come out to seven key recommendations that we think are important for you data publishers to use and maybe add to your data to make it more discoverable. So the first one, as I said earlier, was using schema.org in your HTML. There are a few different formats that you can use, but JSON-LD is Google's preferred format. And as we're in a Google world now, I would definitely recommend that JSON-LD is the way to go. The second one, again, as I said earlier, was using sitemaps to make sure that your orphan pages can be found. Sitemaps should generally be in XML. They should be included in your robot file, and they should be submitted to Google via Google Search Console to make sure that Google is aware of your sitemap and can crawl those orphan pages. Recommendation 3 is about ensuring pages have their own URL. Some portals like to use JavaScript as a way to show multiple metadata records within the same page, but this actually harms Google's view of that website and that URL, so we'll mark them down and make it less discoverable and lower in the rankings. As a sweeping statement, number 4 is apply SEO techniques. All the things we've already gone through in this presentation. So optimizing metadata, you have control over that as a data publisher, what you put into your metadata, making sure it's complete, making sure you have short, concise titles where possible, making sure in your summaries that you're using like semantically enhanced with full sentences to make sure that Google recognizes that you are using that it is a summary and you're not just putting random keywords in to make it try and assess it better, because that doesn't work. Recommendation 5 is again applying the techniques that we've mentioned to URLs. Optimizing your URL link, if it's possible, is generally beneficial. But also, if you have already put data up and in the past and you update that data, actually using the same URL and using this is really helpful, because the web page will most likely already be indexed. And if you don't use it, some of that authority that URL has might be lost. Recommendation 6 is about improving governance around published metadata, and this should help stop the duplication across different sites, for example, where it's unnecessary. Sometimes for data.gov.uk, you'll see different publishers publishing and duplicating the same metadata and data, which isn't ideal. So Marianne in her report has suggested, for example, introducing annual reviews, actually deleting data that is no longer relevant, ensuring that only data that you want available is available. Generally, we would say avoid duplication of metadata where possible. The only thing I would say for that is, if it isn't possible, make sure if it's on you've got metadata on one website and the same metadata on a different website, make sure that they're consistent, or at least or preferably identical to each other. This will help misunderstanding from users if they see what is meant to be the same thing and they've got two different descriptions, it might make them unsure about what the difference is. In reality, there isn't any.
Claire, you have 1 minute.
Yep, I've got one more thing to say. Recommendation 7 is about understanding how your users search for your data. This is really important. This is something we looked in other work streams within this project. And this could be looking at Google Analytics or Google Search Console, but also doing user surveys, user research, anything like that. So for us, this has led to using an SEO practice guide that we have produced and is available on the Geospatial Commission website. And we are about to start a DD3. I've added some links at the end for a summary report and also some other tools that were produced.
Okay, thank you for your presentation. There are some comments made in the chat, so we keep it to later. I think some could be interesting to discuss, but let's continue now because we have a tight schedule for the time. The next presentation will be from Francois de Prunière, which is titled the GeoNetwork 4.0, the metadata version 2 Elasticsearch and a project update. Are you ready, Francois?
Yes, hi everyone. So with Paul, we wanted to make a project update on GeoNetwork side. So next slide, Paul. So with Paul, we have been working on GeoNetwork for a couple of years now. So Paul, you know from GeoCat and me from Titellus. So the next slide, the table of contents. So on the update, we are going to highlight what has been going on the GeoNetwork project, mainly on the coming version 4, which is a migration to Elasticsearch. So a major rework of the search engine. And then Paul will present the improvement we have been working on about the Inspire Technical Guidance version 2, and what are the future plans regarding OGC API. So you probably all know what GeoNetwork is about. So it's a catalog application focusing on discovery of geospatial resources. So it could be maps, datasets, services, applications, non-geographic data in some cases. It is quite well used for Inspire to provide discovery services at local level or even at national one. It supports different type of models. So the main standard use is ISO 19139, which is the one needed for Inspire, but it also supports the latest ISO 19115-3, which is an update of ISO 19139. For example, in the Wallonia region, we have a catalog using this latest standard. We provide different API to import, export records, and so on. One component is also, it is not used in all the GeoNetwork instance. Sometimes it is turned off, but we provide a web mapping application, which also allows to interact with data. So you can make a catalog of maps and provide the maps, see the maps easily in the web mapping framework. So the version 4 is something we have been working on for a couple of years now. We started in 2017, mainly with Ifremer, working on the map viewer application with the goal to be able to index WFS features and to provide the capability to easily browse those datasets from the map viewer. So be able to create facets, easily filter the large datasets using the map viewer. Then we also had quite some requirements to analyze what is in the catalog and analyze the quality of the metadata and try to improve the quality of the metadata. So for this, we have been adding to GeoNetwork 3 the capability to index the content of the catalog in Elasticsearch and be able to use tools like Kibana to to make dashboard on top of your catalogs. So this version 4 will basically update the search part of GeoNetwork and use Elasticsearch instead. So we will have a much better and much faster search results, which will be much more flexible also. The idea is to be able to scale the application, which is currently an issue with the way we are working with Lucene in version 3 and before. So this will help to deploy multiple GeoNetwork instances. With Elasticsearch, we will have much more flexibility on the search. We can search from similar records, so compute similarity between different metadata, search by synonym, improve the suggestions. So for example, you will be able to search with phrase, not only one word or stuff like that. Better support plurals, for example. We will have better control over ranking, so you can promote specific type of documents. For example, a series may be get an higher score than a record which is part of a series. So the entry point will be a series before accessing all the components of the series. And the spatial search is also part of Elasticsearch. And in current GeoNetwork, it is a GeoTools which is handling the spatial part after the search is made in the index. Also, one benefit is that other tools can access the index. And for example, Kibana will be able to create, you will be able to create dashboard from this. So dashboard can be presentation of what is in your catalog, but it would be also more focused on catalog administrator, so you can more closely follow what how many records have a long abstract, an abstract with more than one word, and how many keywords you have per metadata record, if you have an overview every time or stuff like that. The idea also for moving to Elasticsearch, so on the next slide, the idea is to have a more flexible architecture at some point. So it will make the installation a bit more complex because you will need an Elasticsearch instance, but we are providing a Docker setup, so you can easily set up the version. And at some point, we would like to be able to, for example, set up a GeoNetwork only with the search and the harvesting if you don't need the editor or stuff like this. So we are also working on splitting and making components to improve the architecture of the application. So the version 4, we made the alpha version 2 weeks ago, which is available for download, but we are still work in progress on this, and we are currently testing it with EEA and Wallonia region, so testing on real life catalogs. So now Paul will explain the status of the Inspire technical guidance too on GeoNetwork.
So let me continue from this point. So I start with a couple of logos. So just to indicate that GeoNetwork community is really a community of various organizations, and each of them brings in a small part of the work to make this successful project. So those are the organizations contributing directly to the Inspire implementation in GeoNetwork. There's a lot more. These are a couple of them. So Inspire 2G was around for quite a while, but it only got required last January. So it's not really relevant to have full support in GeoNetwork. So what I like about 2G2 is that it really tries to make this bridge to the more webby side of the internet. So there's a lot of introduction of URIs and common ontologies, and all sorts of mechanisms, mostly the anchor, to populate various fields with links to common URLs. And that's mostly done to the Inspire registry. However, the Inspire registry itself also links to common ontologies out there. So the big advantage is that we make these crosswalks to DGAT app more easy to do. And since DGAT oriented profiles are a bit the future of metadata discovery, this is a very good approach. I have an example of that. So in TG13, there was this distribution format which had a character string having geopackage. So that's very, if you want to do a mapping to DGAT, that's very flexible, but not very tight. So with the TG2, they require a code list from the Inspire registry, which itself links back to the IANA code list, which is used by DGAT. So the mapping to DGAT for this element will be quite tight, and so we'll be able to crosswalk in both directions. So what we've done in GeoNetwork related to TG2 is mostly on those Inspire registry and concept schemes. So you're able to import a code list from the Inspire registry, and there's all sorts of widgets to populate fields from those keywords from the Inspire registry. One example is the spatial scope and priority data set. Then there is the option to validate against the Inspire reference validator. We have not implemented full validations against each of the TG2 use cases, but we delegate this to the reference validator. So most of these things are available in the 3.10 or 3.8.6 already. Some screenshots here. So when you start the Inspire validator for a certain record from the current interface, it will pop up the validation result in a new window. Maybe at some point you can make a more integrated experience, but this is what it is for now. The other screen is about the capability to import various code lists from the Inspire registry. So how do we as software development companies engage with the Inspire community? Of course, you see our posts from the various platforms, but within our community, we facilitate the Inspire use case with a Kanban board. It's kind of like a clustering of issues related to Inspire, and you're very welcome to look at those issues there, comment on them, or even create them. It's always a bit a challenge. How do you add a specific Inspire feature to GeoNetwork? Because Inspire is just one of the use cases that we have. So it will always be some kind of a configuration saying, okay, I do Inspire or not. Okay, if not, if I do, then this button is activated. But still, so I would advise you to join the discussion in the various community channels. But as in general, also an aspect that I like about GitHub is that you can quite easily reference issues in GeoNetwork issue tracker to reference to issues that exist in the reference validator or in the specifications, the test suits. And another option is well, look around you in this chat, for example, if you see people form an alliance to raise some funding for development. And I would also love to hear if you have alternative ideas on this topic. So please use the chat or one of the platforms. This is a topic that we've heard a lot about in this conference this week, OGC API Common, and the upcoming OGC API records. We'll hear about that in the GeoAPI presentation after this one. But we've seen this OGC API features work from OGC really becoming concrete. And now next steps are taken to do other topics like coverages, but also records, which is the name for Catalogue, the old CSW. And so for GeoNetwork, the whole Open API thing is kind of natural, because GeoNetwork is already based on the Open API specification. So having open OGC API features records would be not such a big implementation, and we probably are going to do that soon. And we try to use that opportunity, also the one that Francois mentioned, to create a more lightweight, scalable, standalone search component around that specification. So you can also deploy GeoNetwork partially. Well, the main capabilities of that component, it would be that it offers you HTML, XML, JSON, LB encoding for records, the search experience on top of that, and of course the existing indexing mechanisms behind that. Well, what we also do is that we include the schema.org tags for the HTML encoding, so those records will also be easily found on Google Elasticsearch. Thanks. These are 2 events for your agenda. So 17 June, next week, we have a FOSSO UK, which is all of these things are virtual, so quite easy to follow from your house, where we have a session on search engine optimization in GeoNetwork, specifically around the topic and experiences in the UK. And the week after is the GeoNetwork user meeting, where we are going to spend a full day discussing all various aspects of the GeoNetwork 4 release. Thank you.
Okay, thank you, Paul and Francois, for the presentation. We have some nice things to look out for in the coming period to continue the collaboration in that field, so that's interesting. We are now going to the next presentation, which is from Sylvain Willet, which is called Linked Data, the glue within interoperable information systems. Sylvain, are you ready? Don't hear anything yet.
I see your screen.
Presentation is coming up.
Yes. Sylvain, we don't hear you yet.
No. Can you unmute your microphone? Yeah.
Yeah, can you hear me better?
That's fine.
Super.
Yeah, sorry, I'm on the phone right now. This is, a small journey we've written with Abdel, works together with me at the RGM on how introducing drops and hints of linked data progressively in our spatial information systems is really helping to glue information together and make it reusable. At least that's the way we hope it's going towards. Next slide, see. Yeah, so let's start with the context and with what we will call here the previous generation of OGC APIs. And here the example will be focused on FX, WFS, and SOS, given that other presentations already spoke about catalogs, for example. So they're based and designed from the 80s and 90s or in the early 2000s. They helped brought a lot of SDI's spatial information system to the web, but yeah, there are buts. They are packed to the web and crawlers to access to them. I mean, you need to know the catalog, where to search for the API endpoint. You need to know how to interact with the catalog. And then when you magically manage to find the API endpoint, you need to read the spec to be able to dialogue with it. So this all inspired dynamics by all this. That's really good. That trigger momentum, but we need to admit that we expose data in a siloed way. So first idea is, data is naturally linked. It's projects and systems that close them in silos. So why not linking data content? So still using the previous OGC APIs, we started to assign HTTP URIs, applying W3C best practices to features, feature instances, and stuff. An example could be like linking a station to river, an aquifer system to its part, etc., and also linking to control vocabularies. So this is, now resist the idea of dropping a GML example. So previous GML with a hint of linked data in it, like references to features in green, and in purple, I guess you see it in purple, references to code list. step one. So from this, you can already build nice things. This is a screenshot from the plugin that has been reused in the Inspire community, that is the GML application schema toolbox for QGIS, and we actually had a couple of videos about that topic in previous Inspire camps, so just a link. You can already ingest data and traverse to other data instances. That's interesting. And even with what we call previous generation OGC APIs, that's already a better experience. But okay, data starts to open up, starts to cross a bit silos. That's already a better experience, but API are still opaque to the web, and data semantics are inaccessible to the web of data. So let's come with idea 2. Why not serving data in a web-oriented approach? So there is an important turn and change in OGC specs. Many of you in the webcom already know that, so I'm going to be short. The OGC WSC collaboration and many other things helped those OGC API specifications move more toward web consumption. Now we have OGC API line with feature, catalog and stuff, sensor things API. Sometimes they are referred to RESTful services. Each API is described by documentation meaningful for the web. It was completely written for some, like WFS2 to OGC API feature that, okay, no retrocompatibility, okay. But if that's the cost for better reuse of data, why not? It was written by OGC staff, this kind of sentence. Most of those API target OGC JSON, not OGC, target JSON family, I would say so, JSON, your JSON representations. And there is an emphasis on linking things, data, API operations, but also data content, targeting what is called ATOAs, a lot of hypermedia. And the idea is that a client could work by following link between resources, and that's the way of the web, not actually the modern web. That's the way the web is designed, linking resources. These are screenshots of, yeah, this is already doable, OGC API feature. That's our screenshots from GeoJSON provided by GeoServer in that context. This is an example of feedback from response from Sensor Things API, where the JSON content provides all the client needs to go further down, search for more information. So, yeah, after that attitude, APIs endpoint can be automatically discovered by machines, but still semantics are not accessible, I don't have enough meaning to contribute to the web of data. So idea number 3 is why not expressing data semantics differently? And then I leave the floor for Abdel.
Yeah, hello everyone. So to go on that question, why not representing the semantic differently? We mean by that, why not follow the good practices and the technology that are proposed in the W3C standard context? I mean by that, the way we represent semantic in the semantic web or the web of data. And in that sense, some experimentations have been carried on in the in OGC. We participate in those, mainly the first one, which is ELFI, which is an experimentation about linking environmental features and sampling features, but that domain objects and observation and sampling features. And in that sense, we tried to push to a way by using standards that are compliant with more open usage and make it compatible with the modern search engines. And the second experimentations, which treats mainly the web resource model for presenting network between different representations of environmental features, and to see the behavior of applications while consuming that. And we based the work on the on OGC APIs as building blocks. The idea in these experimentations and other works that are being done in this context is to be more open to W3C best practices and standards. And it was decided in these experimentations that JSON LD would be the serialization format of RDF model, because it brings many features and many words together. Mainly because it, as it has been said earlier, it allows an easier indexing of search engine while using schema.org, and it also gives the way, since it's an RDF representation, to reuse ontologies coming from different scientific domains, and also while keeping the main idea of using HTTP URIs and bringing content negotiation, behind those URIs. So if you can go to the next slide. One of the ideas of going behind using more open semantic technologies is to provide a way to better I'd say manage and provide controlled vocabularies based on linked data principles. This is what we are doing in BRGM, for example, by providing URIs identifying concepts and vocabularies and concepts in those vocabularies with multiple representation, with content negotiation, and they are, of course, being federated by the Inspire Federation Register. So it all comes together with this way of representation of semantics, and it is also an effort going with the feature API supports of JSON LD. For example, the one that has been implemented with GeoServer, the JSON LD extension, or the one that had been done with the PyGeo API in the sense of providing JSON LD representation for spatial objects. It's the same thing that has been also carried on by if you can go to the next slide, Siva, about the Catalogue API. Also, it supports there's an effort for making it supporting JSON LD representation, as has been said by Jean-François earlier, and there's an effort also to make it in the same paradigm representation of observation in sort of things API, which she's been discussed in the selfie experimentation right now. And the benefit of that is to go from less open world, let's say, to a more open world, which is being compliant with any linked data, let's say, application or client. So it would open the everything to a more open world, which is the linked open data world. So the benefits, it's not only for structuring the data or making the semantics easily understandable, but also to make it easily indexable by search engines. And I let you, Sylvain, continue on the next slide.
Yeah, thanks, Abdel. So if we generalize a bit, it's quite a journey. I mean, I had the feeling I was kind of telling the story of when I started to do that job and started swerving in 2020. So a rough summary is that, let's say, the previous era, DK was bringing APIs to the web and clearly inspired Dynamics in this, and using this previously, this is web services, and I'm referring here to Inspire Network Services Guidelines, the word system today. Now we have the chance for spatial information system, let's broaden that, environmental information system, to contribute to the web of data. And here, linked data and semantic web philosophy, best practices, and tools, let's say, that are at a certain stage really mature enough for infrastructure to do so. Yeah, I've already wrote that third note that always spoke about that. We could have detailed metadata, but that's been we spoke about a lot, and gonna be spoke after, I think, of the next presentation. There is also work to support is not a good word, express in ontologies the amount of domain knowledge that has been actually written, formalizing OGC semantic specification, and of course the Inspire same data specifications is a huge amount of information, and part of this exercise is being carried out during LC-CLC exercises. They're currently being published by OGC naming authority, and here it's more GeoSciML part of groundwater ML hydro features and their dynamics around observation and measurements as well. I mean, you understand that we directly aim to put HTTP URIs on everything, feature code list entries, APIs, datasets, just to create to link everything together.
Sylvain, you have 1 minute.
This is the last slide. So the conclusion, introducing data and semantic web information systems. Data providers still provide us data, so we still hold this. Sometimes it's a psychological issue. In a way that allows both APIs and data to be discovered and linked to, so just more reuse, there's less loss of time searching for trying to understand data instead of producing new domain content. So ultimately, our domain experts should be have more freedom to actually do their work, not part of IT. I just copy pasted a lot of links at the last slide to save you the burden, and I think that's all.
Okay, thank you, Sylvain, and I look up the name Abdel Fattah for your presentation. We continue to the next one, which is carried out by Angelos, Paul, and Tom. I think Paul will start the presentation, so floor is yours.
Yes. Myself. Okay. So this presentation is also on behalf of Tom Koulidis, but he's based in Canada, so he's dreaming about metadata right now. So it's me and Angelos presenting this one. Short overview. We have a lot of topics, so I'll go quickly. Let me start with this slide. I always like it. You've probably seen it in a lot of presentations. This is from the GeoNetwork data on the web experiment a couple of years ago, and it really expresses clearly what people experience from OGC services, the old ones that we're behind the brick, and the rest of the web cannot see us. And so we have this Geo API evolution. All these standards are from the 90s. So when we were when XML was very prominent, and we had all these terms. Then in 2000, Google Maps came with its Slippy Maps, and we had the Web 2 and all the Ajax and JavaScript. But now we're going to the 2020s, and we're entering the age of Web 3, where we have structured data, machine learning, artificial intelligence, but also democratizing software development. Software development should be easy, and anybody should be able to do it in his kitchen. So there's now OGC APIs. OGC APIs originated from the OGC plus W3C Spatial Data on the Web Interest Group, and they identified that the current OGC APIs were hard to access by non-specialized users, and search engines couldn't go in. So the goal of that group was to create best practices for data on the web. And based on that work, all the OGC API common work started. That started up with features, the old previous WFS, and then common. And these days we're talking a lot about OGC API records, maps, coverages, and processes. Some very generic things to mention here is that it uses the mechanisms of the web. So these services are in the web. They're built on the Open API specification, and they have HTML and GeoJSON as primary encodings. Developer friendly is a very important term here, and lightweight. So we have a base standard which is very lightweight, and then via plugins you make more complex situations. So previously we had this long parameterized URLs. Now they are easy to read. In one of those OGC hackathons, the ByGeo API came to existence. So it's a geospatial data server where which exposes only the new generation of APIs. And therefore, is quite lightweight compared to the other server projects out there. It has so it's based on existing web modules. Therefore, it's not it's a lightweight implementation. It uses currently implements all the core abstract APIs. And it is web framework agnostic. So as a default, we use Flask, but you can also plug other Python web frameworks. Based on a YAML configuration, the Open API specification document is created from the data. And it is very pluggable framework. So you can easily plug in new data providers that fit your backend. We have various deployment options via Docker or pip, and it uses minimal dependencies. This is a small picture about the architecture of the project. So it has a pluggable backend, various backends. Then there's a core module, and on top of that, you apply any of your favorite Python web framework. HTML schema.org is relevant in the scope of this session. Discovery. It's an aspect that I worked on quite a bit in the project. So HTML is a primary encoding in OGC API Common. It means that if you, as a user, would end up in some WFS feature, you would always receive the HTML representation of that feature. If you are a human. If you are a machine, you probably get the GeoJSON or XML encoding. These things are inherent in how the web is designed, and you find that back in the new OGC API Common specifications. So it means search engines, when they are crawling an OGC API features or OGC API records service, will start indexing that content automatically. Schema.org is a layer that fits on top of that, which is not defined by the standard itself, but it's a thing that is very common to apply on top of the standard. In that you then define the things that you are exposing via that service. And in ByGeo API, we implement the schema.org for collections and records and features as being catalog records and schema.org datasets. So they feed into the Google dataset search, for example. And in a sense, you don't need a catalog anymore because it's the search engine can directly extract that information from the feature service. This is a picture from the Google dataset search when you find one of the ByGeo API demo datasets straight from the OGC API features implementation. So what about Catalog? I give the word to Angelos.
Hi everyone. So I'm going to share my screen now because I'm going to do a short demo. And
let me stop this.
Can you see my screen? So I'm now going to focus a bit on the catalog and the discovery aspect of the presentation. So what about catalogs? What happens now in the catalog world? We currently, obviously, we have the CSW specification, which for Inspire purposes, we still use version 2.0.2. But we do have the CSW3 version that was released in 2016. And we have many profiles to select when we want to.
Angelos, sorry, we're not seeing your screen.
Oh, Sorry.
Yeah, excuse.
Trying to, okay, let's try again. Yeah. Can you now see my screen?
Yes. Thank you.
Thanks.
Thank you. So I was discussing about CSW and how we have we have a core profile based on Dublin Core in CSW3, and we have all the application profiles to select from. And this has been adopted by many organizations. In Europe, mostly version 2 of the CSW is being adopted, but CSW3 is there and is getting some adoption. And we have many open source tools that can serve in this purpose. Like we have integration in QGIS now with MetaSearch plugin, and we have PyCSW and GeoNetwork and Degree as servers that are certified against CSW, and we have Python libraries and clients like OWSLib. So but it has been a challenge to balance simple search that we all want with the complex metadata schemas like ISO. And we also have a challenge between, easy of development, as Paul mentioned before, between, RESTful APIs that are very common now and being still at the XML, using an XML based server side. So this is where OGC API records comes in, and this is the new catalog specification. It was initially named as OGC API catalogs, and the standards working group was formed in 2019. But then it was renamed to OGC API records to align with all the other API names. And we are now, as the software, as the working group, we are working on GitHub, and we have already released a draft specification, which is on GitHub, and I'm giving you the URL here. This is an ongoing process. Obviously, we are following up on what has been done in OGC API Commons and OGC API features. So we are adapting the catalog to be closer to the OGC API features world, and this is what we are. This is the state we are in right now. So instead of having the XML and the SOAP and the previous APIs, we now can directly with the RESTful API search for items and provide queryable directly. And search for, like here, this example with the bounding box. So data is going to be returned primarily in HTML and GeoJSON formats. Obviously, output format is still a discussion because we are going to propose that we will have several profiles that can be supported. But the core specification will only support a basic set of filters, and we are going to use these similar parameters like used in opensource geo and time specification. So here you can see an outline of the specification already published on GitHub, and I'm going to now move into how this has been already implemented in PyGeo API. So PyGeo API, since we are also involved in the software in the specification working group, we are following very closely to the new catalog specification, and we are implementing the specification as this evolves during this time. The architecture of PyGeo API and the extensibility that it has allows us to bind easily to specific search backends. So we can bind to Elasticsearch, Solr, obviously Postgres, or GeoPackage or something similar. And also there is the ability to actually use a backend that it's an already another CSW, for example, implementation. So we are moving towards a solution that will help everybody, even with an existing catalog, to be able to offer a new API, the OGC API records on top of it. So here I'm going to show you a little bit of a demo. We have a sample instance of the new catalog, and we are using discovery metadata from the Meteorological Service of Canada, where Tom is working, and this is a part of the WMO information system. So I'm going to now.
We have still 1 minute left, so try to keep it short.
Yeah, sorry. So I'm going to show you a demo here. So we have here, this is the landing page of the catalog, which is similar to a catalog that has features. But here we can see the collections that are available here, and this is all in HTML, but here you can switch to a JSON representation. So we can see the queryables of the catalog that are listed right here, the default queryables, and we can easily browse through the items of the catalog. And every time we want to select a catalog record, we can click it directly, and we access the catalog. We access the metadata record directly on the web. And at the same time, we have JSON and JSON LD representation. So this is how a record of the new catalog specification looks like today. So I was planning to talk a bit about the stack, the stack specification. Unfortunately, I don't have enough time. Just an overview, we have there is also this spatio-temporal asset catalog specification that has been formed within OGC, but also with members of the community. This is mostly about Earth observation and spatio-temporal assets, and this specification is also being supported by PyGeo API. So we can also support stack items and the stack catalog directly from PyGeo API. I don't have enough time to show you the demo, but if you go to the homepage of PyGeo API here, you will find also the demonstration of stack. So sorry about taking more time. Thank you.
Okay, thank you, Angelo. All the presentations will be made available so people can have a look at what still they have missed now. But since time is pressing, we will move on to the next presentation. This is by Geraldine Nolf, which is called From Niche to Mainstream, Lovable Data, Including Metadata. So can you prepare?
Yes, and can you give me the right to share? Okay, normally you can see now the screen.
Yeah.
All right. Hello, I'm Geraldine Nolf. I don't know if I can move. Yes, I'm Geraldine Nolf from Informatie Vlaanderen, Government of Flanders in Belgium, and this last session zooms in on the digital solution Flanders developed to close the gap between metadata of geospatial and open government data worlds, clearing the path for the inclusion of the other data domains, for example, APIs and statistical data. And a small demo through slides will be shown of the DCAT AP plugin in GeoNetwork open source solution. And this session will also elaborate on the concept of a marketplace, as we call it for now, as a lovable application for the hungry data society. Okay, yes. Previously, public sector data providers only had to publish their data in geoportals to convince users to make use of them. Nowadays, the government has to seduce users to use their public sector information. They have to be convinced of its quality, its up-to-dateness, and its value. Today's users demand much more than just information that is available. So the government of today, therefore, has to leave its niche and become more mainstream, make a switch from government data to truly lovable data. Data had to be fair. findable, accessible, interoperable, and reusable. But today, the user-friendliness of portals and of the data is very important, the most important. Ease of use is important to really convince users to use and reuse public sector data and its APIs. At the end of this session, I will elaborate on the lovability, and now I zoom in into the findability. So governments publish information from different domains: geospatial data, open data, statistical data, archival information, etc. Each of these domains comes with its own metadata standards. As these are often not interoperable, it is a complex task for public authorities to publish their data in line with the regulations of the different data domains. We need to solve the semantic differences in the diverse metadata standards and profiles in order to create efficient, once only, and sustainable methods for data providers to describe and publish their public sector information on the web. By solving these semantic differences, we will enable the data providers to describe their information once only while adhering to all regulations and guidelines applicable to their data domains. So we started to close the metadata gap between the geospatial and the open government data worlds, clearing the path for the inclusion of other data domains, for example, the APIs. In Flanders were a lot of metadata standards, portals, and systems, as you can see over here. And that is why we brought Ms. World and Mr. Cube together and opened up that way the data. By bridging the gap, using the same metadata management system, GeoNetwork. The data domains are in the vertical columns, and they all have an own standard to describe their metadata into. A system where you can manage that metadata and a portal to publish the catalog. The GeoWorld is described conform ISO Inspire. In GeoNetwork, with the 19,000 series of ISO, exported in that XML and published into GeoPunt and the Inspire portal. The open world uses DCAT-AP as a best practice standard, and we made a profile for that, DCAT-AP, into the same GeoNetwork system, and the records are exported into RDF and published into the open data portals of Flanders, Belgium, and Europe. So the data, the open geodata, should it be described then again? Now, no, we export it via the GeoDCAT-AP transformation to the open data portals as well. So we built a DCAT-AP plugin for GeoNetwork, and we are upgrading our GeoNetwork instance into the 3.8 version, and we are close to the beta release, in fact. Now I am zooming into the DCAT-AP plugin we have built. GeoNetwork is an XML-based system, so we can define an XML scheme based on the DCAT-AP standard, the version 1.1. And already we are at version 1.2. It's a built-in, a plugin for GeoNetwork, and now we are already on version 3.8. It was developed by him and funded by Informatie Vlaanderen. So you see the beta URL over here and in the chat, and the code is available as open source software on GitHub. So please use it too. The features of the plugin are listed over here, and I will zoom on some of them in the few next slides. The first feature is an XML schema that fully resembles the RDF syntax of the DCAT AP. Then we created a harvester that normalizes that DCAT RDF into XML. We needed, of course, an editor to have full control for editors typing in their metadata, and we use controlled vocabularies and add licenses via templates. We use the multilinguality of the core GeoNetwork, and we help the editors by creating a validator like there is in the core, but now for the DCAT-AP. So it is a validation in two steps. First, an XSD schema validation, followed by schematron rule sets validation. And final, the RDF endpoint that exports the created metadata into the RDF again. That can be harvested by CCAN portals, for example, as the most open data portals are using. First of all, the harvester on the input side. XML is a nested data structure, can be queried with XPath. RDF is a graph-based data structure that can be queried with Sparkle. So if you look at the figure at the green boxes and arrows from the right to the left, you can see that the DCAT RDF is Sparkle selected and XSLT harvested into DCAT XML that is fitting into the GeoNetwork environment. The input can be Turtle, RDF XML, notation, tree, and JSON LD. And then we created an editor with a simple view and an advanced view to really edit the DKTP records over there. The options of multilinguality are foreseen, like you see over here, Dutch and English in the DKTP codings, controlled vocabularies of DCAT as thesauri, and we reuse the existing controls of the core GeoNetwork, for example, spatial extent. To help the editors create their metadata, we made a validator with 3 schematron rule sets. The first is the mandatory rules conform DKTP version 1.2. A second one has all the recommendations of version 1.2. And then additionally, we have an extra rule set that is mandatory for publishing into our own Flemish open data portal. And here you can see an example of then such a created open data metadata record. This is the dataset view you can see of the port of Antwerp. This is the distribution view as well, where you can see in this case CSV is directly made available into this URL with an open license over there. And then finally, at the output side, there is again the DCAT AP RDF endpoint. So if you again read the green boxes and arrows, you start over here. There is the creation of the DCAT XML in GeoNetwork. And now via the standard GeoNetwork API, we are harvesting this with an XSLT trivial procedure on top of it into DCAT RDF again, so it can be sparkled again over there. So the output formats are RDF and XML, and the endpoint is supporting W3C LDP paging and Hydra paging. Is there room for improvement? Of course. On the input side, the harvester, we could do also the paging support. On the output side, from GeoNetwork RDF endpoint, we could have more formats. Of course, the schema.org integration could be done too, and this is not in place yet. The timeline, the beta release was already last year, but the production release is waiting to be released together with the GeoNetwork upgrade. That is the 3.8 and the Geo migration to the TG 2.0, and we're close to the beta release and should go to production possibly near the end of Q3 this year. So this proves that we can move towards one catalog, as you see over here. The 6 records above are the typical geospatial ones. The 6 records below are typical open metadata records. You can see a detail of each of one, and you can see over here the list of harvested catalogs, the CSWs, as well as the DCAT feeds are in place. So my goal is really to come towards a reusable reference implementation and harmonized strategy for metadata catalogs. So this is really an umbrella catalog, and we call it the information catalog. And by closing the first gap between metadata of geospatial and general open government data, we know the other data domains can and will follow. For example, the closed data, as you see over here, and the APIs. Both of them, the standard is nowadays being analyzed. We think DCAT AP version 2 is really a good example to start with. And that way, it is keeping it simple to describe and publish for data providers their data with the once only principle in mind, reaching the widest possible audience and being at the same time in line with all regulations applicable to their data domain. So instead of foreseeing for each portal, for each data or information domain, there is from now on the possibility to gather them all into one very user-friendly portal based on that umbrella concept of the information catalog. And as I promised, I would end the session now by elaborating on what we had in mind for the future. And that is the concept of a marketplace, as we call it for now, as a lovable application for the Hungry Data Society. So, in order to create true ease of use and to reach the widest possible audiences, governments can provide a marketplace where users can find all possible public sector information really on a plate. So, the marketplace is a user-friendly digital solution where data can be easily discovered and understood, and where users can easily find what they are looking for, filter it, etc. A place where an end user can view the data, have a preview or a geospatial view on a map, where he can download it if he has the necessary rights, of course, but also a place where a developer, for example, can start processes to connect to closed services, for example. If he has the necessary rights, of course, to implement these in his own client solution needed for his organization to maintain critical business processes, for example. And all of it should be done in a few clicks, very user-friendly and very easy. And from that moment on, our catalogs will transform from just findable ones into lovable ones. If you have further questions, don't hesitate to contact us. You see my address and the team, and I'll thank you for your attention.
Thank you, Geraldine, for your nice presentation and showing us the way to lovable data, specifically metadata, and also bridging the gap to other data as well, the spatial data. So we are coming to an end of this session. As was expected, not much room for discussion, but I have seen in the chat a lot of questions already answered and given some additional information, so have a look at that one. We will make the presentations available and also take note of what is asked in the chat to have some volunteers for documenting and other work which has to be done to make data discovery more useful for the community. So thank you, everyone. Specifically,
maybe we have room for some small questions, or should we break up, Karen?
If you don't mind going over time, then we can continue for those who want to stay. That's not a problem for me.
Yeah.
So are there pressing questions?
There were some questions on Slido. So let me add some. Feel free to go. This is the bonus time. so there's Carmelse who asks to Clara Boyd. Are you still here, Clara? Maybe. About the recommendations from the UK. Well, maybe it's a question to me actually. I don't know. Be incorporated in GeoNetwork 4. The point with the recommendations, Clara, I let you after this one. So the recommendations document from the Geospatial Commission is a really nice read. It's a recommendation, but it involves technical aspects as well as more content aspects. And for sure, the technical aspects, I think they will be covered in GeoNetwork. But the content aspects, maybe you can share your vision on that there.
Yeah, so the content is obviously we're making these recommendations based on our research, and if publishers want to take up those recommendations, I think they could be really valuable to anyone that wants to use them. We've also produced various other recommendations that can also enhance metadata on various portals. I did also see a question about my comment on the summaries and the 120 characters. I just want to
You still there?
Yeah, apparently there was some discussion if it should be 100 or 120. We'll see that on the chat at some point.
so just to clear that up as well.
Sorry, we missed a bit of you, or was it just us?
Sorry, was that to me? I didn't hear that.
Okay. let's continue. So Anonymous asked if there are some, that was a question to you, Jan-Dirk, if there are some criteria related to licenses when evaluating the quality.
For the first presentation, yes, there are criteria related to licenses. Very specifically, well, in the last slide, you can find a link to the final report, and we have in an annex all the criteria listed over there. So some things about licenses, I think 2 or 3 criteria which are dealing with that. But in general, if you look at the data, basically licenses are provided, not always as clear as it should be. But if it goes to documents and to websites in general, then it's less easy to find what you can do and what you cannot do with the information which is published by that website. So that makes it still difficult. But yes, we have some criteria on licenses as well.
So any more questions? I see a question about the DGet app plugin, if that's available for the community, Geraldine.
Yeah, dus we are planning to follow 2 times a year at least the core of GeoNetwork. So now it is on the 3.8 and we will follow the next versions. And for now it is really the general DCAT AP, but in the profile we made in the templates, we have the Flemish version for now that is really close to the Dublin core, in fact, with the minus view. So the most simple we could make it for the editors to follow. So it shouldn't be a problem to use it as well for a general version. So that is something that we can work all on in the community, I think.
Francois has the link in the chat. Yeah.
Yeah, correct.
Okay, if there are no other people with pressing questions, then this is your last chance. If not, then I would like to thank you for your attendance, but also specifically the presenters for their presentations. And have a hand. I think Paul will also start the hand as well. Yeah. Hope you have a nice afternoon. I think the last one in the Inspire workshop week. And hopefully we see you next year physically.
Yes.
So thank you all.
Thank you, all speakers and everyone joining.
Thank you.
Bye-bye.
Bye-bye.